In this example, we have to graph the polynomial function and state the domain and range. So here is my function, f of x equals x squared plus 3. So to graph the function, what I'm going to do is I'm going to do it by point plotting. So I'm going to choose some values for x. I'm going to choose -3 through +3. And then one at a time, I'm going to go ahead and I'm going to plug those numbers in for x and find my function values. So I've created a nice little chart here to organize my work, and then once I get my points, I'm going to graph it down below. So my first x value is -3. So that means I need to find f of -3. So if you remember in class, I talked about creating a skeleton every time you plug in numbers into a function. So everywhere I see that open parenthesis, I'm going to replace, or I'm going to put inside that open parenthesis -3, because I'm replacing the x with -3. So -3 goes here, and -3 goes here. So now I'm going to do my operations. -3 squared is +9, plus 3 is 12. So that means f of x is 12. So that means when I inputted an x value of 12, when I inputted an x value of -3, my output value is 12. And remember, f of x is the same as y, so that corresponds to the xy pair, -3, 12. All right, so let's continue doing this for all these values of x. So -2, everywhere I see open parentheses. Now, it's really important that your negative number, when you're squaring a negative number, it has to be in parentheses, because what you're doing, for instance, in the first one where we did -3 squared, that means we did -3 times -3. If you're typing it in on your calculator and you're not using parentheses, you're going to be getting an answer of -9 instead of +9. That has to do with order of operations. If you want to do -3 times -3, you need parentheses around the base of -3. All right, so I do -2 squared, which is 4, plus 3, and that's 7. So in this case, f of x is 7. So my ordered pair is -2, 7. Okay, so let's do f of -1 now. So this is going to give me 1 plus 3, which is 4. So that is the ordered pair -1, 4. Now let's do f of 0. So 0 squared is 0, plus 3 is 3. So my value is 3. So 0, 3 is my ordered pair. Now let's do f of 1. So 1 squared is 1, plus 3 is 4. All right, let's do f of 2. So 2 squared is 4, and 4 plus 3 is 7. So that's the ordered pair 2, 7. And then the last one, f of 3. So 3 squared is my +9, and then plus 3 is 12. So this is 3, 12. Now, before we go and graph it, I want you to look at the patterns that show up here. Look at the patterns in our y values. Notice how our y value, we have a y value of 12, and then as our x values get bigger, from -3 to -2 to -1 and so on, look at what's happening to our y values. So we have 12, down to 7, down to 4, down to 3, and then back up to 4, back up to 7, back up to 12. So you can see we have some reflection or some symmetry here. 12 matches up with 12, and then the 7 matches up with 7, the 4 matches up with 4, and then they meet in the middle right there at 3. So you're going to kind of see that same symmetrical pattern when we graph this. This isn't going to be a straight line anymore. This isn't y equals mx plus b. We now have our x value being squared. So this graph is going to look completely different than a straight line. So let's start plotting the points. So negative 3, 12. And then let's do negative 2, 7. Negative 1, 4. 0, 3. And then we have 1, 4. So you can see how my points are going back up. They were getting lower, 12 down to 7, down to 4, down to 3. Now they're going back up to 4. And then I have 2, 7. And then 3, 12. Right here. So you can see as you look at the graph from left to right, now I'm going to connect my dots with a nice smooth curve. Again, like I said, this is no longer a straight line. So as I look at my graph from left to right and I connect my dots, my graph goes down, but then it hits the bottom and it curves and comes back up. So no sharp edges or no sharp corners on this graph. This is a nice smooth curve that's going through this graph. This is called a parabola, and we will actually be working with these a lot in this class. But I wanted to talk about how they met in the middle right here. Remember where I put that dot before because the pattern kind of met in the middle there at 0, 3? Well, you can kind of see that right there, how the graph, that's kind of like the middle of the graph. On the left side and the right side, they're symmetrical. So it's really kind of cool, the symmetry that these parabolas have. It's almost like if you were to draw a line down the middle here, you could fold your paper over that line, and the graph would match up. Okay, so that's a graph. Anytime you see an x squared in your equation, like we see up here, you're going to be getting this parabola shape. Sometimes they might be in different places on the graph, sometimes they might be upside down, but that general U-shaped parabola, anytime you see x squared in your equation, if you're going to graph it, you're going to see that shape. So that's kind of a clue of what your graph's going to look like. All right, now what we have to do is domain and range. So if you remember domain and range, domain is all the x values, and range is all the y values. So I'm going to put that here so we remember. X for domain, y for range. So domain is going to be an interval, so interval notation, that contains all the possible values for x in this graph. So since domain is x, I look at the graph from left to right. So I'm going to start way out here on the left side. And it's kind of like you imagine yourself working your way across the graph from left to right. And you ask yourself, what values of x are included? Well, if I drop these points down like this, those are my x values on the x-axis. But imagine as I keep doing that, if I keep going out with my graph, not only is my graph getting taller, but it's getting wider at the same time. So I could have some more points out here, like this, and I would still be hitting the x-axis. So as my graph gets taller, it's also getting wider. And its arrows tell me that it's going to keep getting taller and wider. So think wider in terms of right, left. To the left, this thing's going all the way to negative infinity. And to the right, this thing's going to positive infinity for the x's. That's just your x-axis. Now let's do the range. The range are your y values. So now you're thinking, start at the bottom of the graph and work your way up. Well, there's nothing down here. There's no negative y values in this particular graph. My y values don't start until right here at that y-intercept. And that y value is 3. That means my smallest y value is 3, and it's included. And then from there, as the parabola continues to go up, my y values continue to get larger. So my y values start at positive 3, and then they go up to infinity. So that would be the domain and the range.